You've probably heard that data doesn't lie, right? That the numbers tell a story. And you know what? They do. But, and this is a big but, if you don't have the right tools, you can get that story completely wrong. You can be totally fooled. So today, we're going to crack open the Data Detectives Toolkit.
All right, let's kick off our investigation with a really weird one. The data, I kid you not, shows a pretty spooky pattern. The more ice cream we sell, the higher the murder rate gets. I mean, what is going on there? Is that pint of Rocky Road in your freezer secretly plotting something sinister?
Well, the answer, as you probably guessed, is hiding in the data. And to solve this mystery, and to learn how to spot these kinds of statistical traps out in the real world, we need to dive into our toolkit.
Okay, first things first. Before we get into any fancy math, a good detective has to survey the scene, right? You got to get the lay of the land. We need to actually see the clues, see the pattern with our own two eyes. And for that, we pull out tool number 1, the scatter plot.
Think of a scatter plot as our first look at the crime scene. It's super simple, really. You just take two different measurements from the same person or thing, say your height and your weight, and you plot that as a single dot on a graph. Then you do that for a whole bunch of people, and bam, you start to see if there's any kind of relationship, any kind of pattern between those two things.
And usually, you'll see one of 3 basic patterns emerge. First, there's a positive correlation. That's when one thing goes up, the other thing goes up too. Like the more diagnoses a patient has, the more medications they're likely on. Makes sense. Then you have a negative correlation, which is the exact opposite. One thing goes up, the other goes down. A great example is more nurses on a shift usually means fewer patient complaints. And then, well, sometimes you get nothing, just a random cloud of dots. That's no correlation, and it just means the two things you're looking at have absolutely nothing to do with each other.
So seeing a pattern is a great first step. But a good detective can't just go to the chief and say, well, the dots kinda look like a line. That's not gonna fly. We need to be precise. We need a number. We need to measure that relationship. And that brings us to tool number 2, the correlation coefficient, which we just call R. R is just, it's awesome. It takes that whole messy scatter plot and boils it down to one single powerful number. And that one number tells you everything, both the direction and the strength of the relationship. And hey, if you have trouble remembering it, just drag out the R sound. Correlation. Seriously, it works.
So this R number always lives on a scale from -1 to +1. That's it. A +1 is a perfect positive correlation. The dots line up perfectly sloping upwards. A -1 is a perfect negative correlation, a perfect line sloping downwards. And an R of 0? Well, that's our random cloud of dots again. Absolutely no relationship whatsoever.
And the strength is just how close that R value gets to either +1 or -1. If it's a strong correlation, like a 0.92, the dots are all packed super tightly together, like they're hugging an imaginary line. If it's weak, like a 0.25, the dots are much more scattered, but you can still kind of see a trend. So the number really just tells you how convincing that trend is.
Okay, let's recap. We've spotted a pattern and we've measured its strength. Now for the fun part, the really cool part. What if we could actually use that pattern to predict the future? Well, we can, and that's where tool number 3 comes in, the regression line.
This regression line is basically our statistical crystal ball. It is the one unique line that best fits all the data points. The math behind it makes sure it's the fairest possible line, minimizing the distance to all the dots at once. And once we've drawn that line, we can start making some pretty good educated guesses.
But a word of warning. You got to be careful with this crystal ball. If you're predicting something within the range of the data you already have, that's called interpolation. That's pretty safe. But if you try to predict something way outside your data range, that's called extrapolation. And that is a super risky guess. Your crystal ball might just be totally wrong out there.
So, great. We've built a prediction model. But is it any good? Like, is it an A+ model or is it barely passing? We need a way to grade our crystal ball, right? And that's exactly what our 4th and final tool does. It's called R-square.
Think of R² as the official report card for our prediction model. And the math is super easy. You just take your R value and square it, multiply it by itself. The number you get tells you what percentage of the variation or the story in one thing is explained by the other.
Let me give you a real-world example. Researchers were looking at the link between a patient's diastolic blood pressure and how many appointments they had. They found a really strong positive correlation with an R of 0.95. So what's the R²? You just take 0.95 times 0.95 and you get about 0.90,
Or, to put it another way, 90%.
So what does that 90% actually mean? It means that a whopping 90% of the reason why patient appointments vary can be explained by their blood pressure. That other 10%? That's due to other stuff, things we didn't measure. But explaining 90%? That is an incredibly powerful model. That thing gets an A+ on its report card for sure.
All right, there you have it. Our toolkit is complete. We know how to see a pattern, measure it, build a prediction model, and even grade that model. So now let's grab our tools, head back to the crime scene, and finally solve this mystery of the killer ice cream.
And this brings us to the single most important rule in the entire Data Detective's Handbook. I mean, if you remember one thing from this whole thing, make it this. Just because two things happen at the same time does not mean one is causing the other. Say it with me. Correlation is not causation. This right here, this is the key that cracks the whole case wide open.
So why do we make this mistake so often? Usually it's because of something called a lurking variable. This is the hidden culprit, the villain hiding in the shadows. It's some third thing that's secretly pulling the strings on both of the variables we're looking at, making it look like they're connected when they're really not.
So let's close this case once and for all. What was our observation? Ice cream sales and murder rates go up together. What was our investigation? We had to look for that hidden link. And the revelation, the lurking variable, is hot weather. Of course, when it's hot, more people buy ice cream. And when it's hot, more people are outside, they're irritable, and that unfortunately leads to more crime. The ice cream isn't the killer, it's just another victim of the heat. Case closed.
And there you have it, your very own Data Detective's Toolkit. Remember the steps. Use a scatter plot to see the clues. Use R to measure them. Use a regression line to predict. And use R² to grade your prediction. But above all else, always be on the lookout for that hidden culprit, the lurking variable.
So I'll leave you with a final question to investigate on your own. The next time you see a headline that says, "Study shows X causes Y," I want you to put on your detective hat. Think about the patterns you see in your own life. What lurking variables might be hiding right there in plain sight?